Let's create a Spring Boot project. In order to create Spring Boot project, open this website start.spring.io and provide the configuration. So first of all, it's asking project type. So here we will choose Maven, and in language we will choose Java, and in case of Spring Boot version we will choose 3.4.0. So under project metadata, group will be your package name. So here we will use com.ems.springboot. Artifact, we will use EMS Spring Boot, and here Spring Boot REST API package will be com.ems.springboot. Packaging, we will use jar, and the Java version will be JDK 17. So right hand side we have a dependency section to add few dependencies that we need. So first of all we need web, then we need JPA, so then we are going to use H2 database. So these are the minimum 3 dependencies we need for our project: Spring Web, Spring Data JPA, and H2 database. Click on generate to download this project sample. Unzip the downloaded folder and open this folder in the Intel IJ. So once this project opened in the Intel IJ, this will be the default packages. So let's first of all configure Hibernate configurations. So under source, main, resources, there is a application.properties file. So all the properties we will configure here. So these are the configurations we require. So first of all, we can say spring.application.name to specify the Spring Boot application name. Then server.servlet.context-path is to use to specify the context path of the application, the REST API. Server.port to specify the port. Then few configurations of JDBC, like what will be the URL, what will be the driver class name, what will be the username and password of the JDBC. Then specific to JPA configurations, need to specify the dialect class. Then what will be the table generation strategy, that is update, and we want to show the SQL queries or not. To show it, show SQL should be equal to true. In order to access the H2 database from web browser, spring.h2.console.enabled equal to true. We have done with the configuration. Now execute the application and open the H2 console in the web browser. Now go to the Java package com.ems.sb package. Then there is a EMS sb application class. It contains the main method. Just execute this main method. Now see in the console, and the log is saying started this application, and the context path of the application is /ems as we given in the configuration, and the port number is 8080. Now open the Chrome browser or any other browser, then type the URL localhost colon 8080 /ems /h2-console. So this is the default interface of the H2 DB browser. Now here specify the URL, the same URL we mentioned in the configuration file, and username is SA and password is the password. So now we have logged in. We just created the configuration file and executed the application. So there is no table generated in the database. So left hand side there is no table. Now go to the application, stop the application. Now create the entity class. This entity class will represent the database table. Create a class, imply entity, use the recommended and required annotations. Specify the primary key data type, apply name, department. Now use @ID annotation with integer variable, specify the generated value strategy. Create default constructor, create parameterized constructor, then create getter and setter related to ID, name and department. That's it. So we created imply entity class and used @entity annotation and used annotation @table and specify the name of the table. So when this application execute, so it will create a table in the database with name imply. There will be 3 columns: ID, name and department, and ID as a primary key, so we designated with @ID annotation, and the primary key value generation strategy will be auto. Save this application and changes and then execute the application again. Application started successfully. Again, refresh this page. It will ask credentials again, connect again. Now see, in the table list, there is a one table created, EMP, and it has 3 columns: ID, department and name. We can also fire a query. So there is no record yet added, so it's showing empty, but automatically a table has been created in the database corresponding to the entity class. Now next step is create one bean class which will represent this entity. Imply bean. It will contains the same number of variables as we created in the entity. The only difference is the entity is used to interact with the Hibernate or JPA, whereas it's a simple Java bean class. So again, we need both constructor, default and parameterized, and getter and setter. We can copy from here as well, or we can create again. Create default constructor. Then we need parameterized constructor as well. Then create get errand setters. That's it. So till now we have created two classes. One is the entity class and second is the bean class. Both classes have the same number of variables. Now we have completed first level of the application. We have first of all configured the JDBC and JPA configurations. Then we created the entity class, and entity class created one table in the database when we executed this application. And further we created one bean class, that is employee bean class, that we will use in the application. Now next level is we need to create a repository interface. Name it as employee repo and it will be an interface, and extend this interface from JPA repository, and here we need to define the entity class, and the data type we use for the primary key is integer. Now designate this interface as repository using the @repository interface. Next, we need to create a service class. Use annotation @service, and here we will use a repository. So let's auto var it. Now we need two functions. One will responsible to add the employee and second will responsible to fetch all records from the database related to the all employees. Create these functions. It will return list of employee bean, import this list from java.util package and create another method add employee. It will take one argument as employee bean. Now add the implementation of add employee method. First of all, create object of employee entity, and pass employee ID, name, and department. Now use employee repo object and use the method save, pass this entity object. So it will return the entity object and return this object. So we need to convert it to employee bean. So this is a very simple implementation of add imply method. We created a imply entity object and fill with the values coming in the imply bean. Then with imply repo object, we call a method save and pass the object. It will return imply entity object. And further, this object we converted into imply bean and returning from here. Now let's add the implementation in get all imply method. Use imply repo object and call a method find all. It will return a list of imply entity objects. We need to return a list of imply bean, so create a list. Now add a check. LST imply means the records coming from the DB is empty, not empty. Then iterate the list using for loop. Then add this object in the list imply bean collection. In the last, return this object. So we have implemented both the methods add imply and get all imply. Now next part is we have already created repository. We have already implemented the methods in the service. Now in the REST API, we need to create the controllers using which a client will interact with the backend functionalities. Now let's create one class that will represent a controller, imply controller. So there are two class level annotations we need to use and make this simple class as controller at the rest controller, and we have to specify request mapping. And normally in REST API we use version, then the name of the mapping that we given in emp imply. Now first of all create add imply, then get all imply methods here, but before this we need to auto wired imply service. So first of all create one add imply method, and here we need to use post mapping annotation. So this is the default inbuilt class response entity that we will use for response. Now in order to hold the data coming from client, we will use @request body annotation and specify the name of the class which will hold the data, that is imply bean. So here use employee service object and call a method add employee and pass this employee bean object. It will return employee bean object representing to the database row. So same, return it to the client for further reference. So that's it. And let's implement next method to get all employee. So here we will use get mapping annotation. So again we will use response entity. Here we will return list of employee bean. Import this list from java.util. Then use employee service object and call method get all employee. It will return list of employee bean object. So just return from here. Use the response entity class and in the body pass this list employee. So that's it. We have done with the coding part of REST API of employee management system. Let's recap all the components we created. So first of all, we added some configurations in the application.properties file. So here application name, context path and server port, these are the optional, not mandatory, but JDBC related configuration and JPA related configuration. These are the very important configurations when we interacting with the database. So related to JDBC, we have to define the URL where we need to specify the file name. Then driver class name, username and password. And related to the JPA, we need to specify the dialect class. We need to specify the table generation strategy, that is update. And show SQL, it is optional, but we used, so we set it as a true. So whenever any database operation will performed internally, so query will be printed in the logs. And in order to access the H2 database from console, we are enabling the H2 console here using the spring.h2.console.enabled equal to true property. Now next, let's move to the very important class, that is the entity class. And this entity class is basically representing a database table. So here we created a simple class with name employee entity, and to make it entity we used @entity annotation, and to specify the table name we used annotation @table and given the name of the table. So in the database, table will be created with the name EMP, and whatever the name we will give here, the table will be created with the name. So next, so ID is the variable which representing to the primary key column in the table. So @ID is used to specify the primary key, and the generated value strategy will be auto. And then we use three variables because in the table there will be three columns: ID, name and department. Then we created default constructor as well as the parameterized constructor along with the getter setter corresponding to these three variables. So this is the entity class, very important class. After that, same, we created a bean class. It is very similar with the entity class. The only difference is in the bean class we never used any annotations. So it's a Java bean class having the private variables and constructor along with the getter setter methods. Then to represent a DAO layer, we used repository. So Spring Boot provide us a functionality of JPA repository inbuilt interface. So standard database operations like save, edit records, fetch records, search records, these all functionalities are provided by JPA repository. So in order to use the JPA repository, we need to create an interface and need to use the annotation @repository. And this interface must extend the interface JPA repository. It's an inbuilt interface. So here we have to specify the class, means entity class, and the data type we use for the primary key. So this is a very simple code of repository. Then this repository will interact with the database, but we need to create a service, and this service will interact with this repository. So next we created a service class. To make a simple class as service, we used annotation @service. This service class will interact with the repository. So we auto-wired this imply repository and added two methods, add imply and get all imply. So add imply taking one object of imply bean and returning the object of imply bean as well. So repository interact with the entity class. So we created object of entity class and fill with the values coming in the imply bean, and then passing this imply entity object in the save method of repository. So this save method will return object of imply entity which will represent a row of the table which is newly inserted. This method return object of imply bean. So we converted imply entity object into imply bean and returning from the add imply method. So next we created get all imply method. So repository provide us a function find all. So find all method will fetch all the available records in the imply table, and it will return us a list of objects of type imply entity. But this method returning list of type imply bean. So we created another list of type imply bean, added the check if this list has some data, only then we use the for loop and iterate the list, and every object in the list we converted into the imply bean and added it to the list imply bean array list. And finally we returning this list imply bean object from the method. So service class interacting with the repository and repository interacting with the database. But in the REST API, client never interact with the service or repository directly. So there is another layer, that is a controller. So we need to create a controller. So client will interact with the controller and controller will interact with the service. Further, service will interact with the repository and repository interact with the database. Now let's create a controller. So we created controller. So it is nothing, it's a simple class, but to designate a simple class as a controller, we need to use annotation @REST controller as well as request mapping to define the REST API path. So this controller will interact with the service. So we auto-wired the imply service and added the two methods, add imply and get all imply. So add imply will be of type post. So whenever client want to use this method, client will send a REST API request of type post and send a imply data in the form of JSON, and that JSON data will converted into the imply bean object internally, and we used here annotation request body. So whenever client will call this REST API of type post, object will have the same data sent by the client in the form of JSON. This data we are passing to the add imply method of service, and this add imply method returning a imply bean object, and same imply bean object we are returning from here using the response entity. So response entity is a standard response class which is provided by the Spring Boot. So in case of get all imply, we used get mapping. So whenever client want to access this method, we'll send a get type of request from client side. So here get all imply method we called of service, which will return all the implies available in the database, and this list we are returning to the client using the response entity. So this REST API is divided into layers, and very first layer is controller, then service, then your repository also known as DAO layer, and that repository interacting with the database. Now let's execute this application and test the all REST APIs we created using the REST client. So application started successfully on port 8080. Now in order to access these controller methods, these APIs, we need a REST client. So we are using here Postman as a REST API, REST client, sorry. So here we need to define which type of REST request we want to send. So we are going to send GET, and we need to define the IP address, port number, context path of the application, and the request mapping path of the REST API. Here, just click on send. So it's returning an empty list. So there is no record yet added by us. So invoke a post REST API to insert the record. Use here post method. URL will be same, and here we need to pass a body, and we need to send the data in the form of JSON. So we just need to provide name and department because ID is auto generated, and just click on send. So one record is inserted whose ID automatically created one. Now create few more records. So another record added with ID 2. So another record also added. So we added 3 records. Again go to the get API call and hit this API. So it's returning us a list of all the record we just added. So in the REST API, we added 2 operations in the controller. One is to add the employee, which is post request, and one is to fetch all the employee records from the database, which is get request.